Today we're going to answer the longest-standing question: why would any human being who travels to Venus never be able to come back to Earth? Not because of a spacecraft failure, not because we don't have the technology, but because of something far more permanent, something written into the planet itself. That bright light you've seen hanging in the night sky, the one that outshines every single star, is Venus. Our closest neighbor, a planet so similar to Earth that scientists once called it our twin, and it is a place that, once you arrive, will never let you leave. By the end of this video, you will know exactly why. And I promise you, the answer is far stranger than you expect. Because the most terrifying thing about Venus is not the heat, not the pressure, not the acid clouds. It's that Venus, billions of years ago, looked exactly like Earth. Let's start with what Venus looks like from the outside, because it's important that you feel how deceiving it is. From space, Venus is the most reflective planet in our solar system. Its thick clouds bounce back about 70% of all sunlight that hits them. That's why it shines so brightly. That's why it looks almost soft, like hanging in the dark. For centuries, before we had spacecraft, people imagined what might lie beneath those clouds. Some scientists in the early 1900s genuinely believed Venus could be a lush, tropical world. Warm oceans, dense jungle, maybe even life. It was closer to the sun than Earth, yes, but the clouds reflected so much heat. Maybe the temperature underneath was manageable. Maybe Venus was paradise. Then we sent a probe there, and the probe died. The first attempt in 1962, NASA Mariner 2 flew past Venus and sent back the first real data from another planet. The results were not what anyone hoped. The surface temperature was not tropical. It was not warm. It was not even survivable. It was 462 degrees Celsius. That's 872 degrees Fahrenheit. To put that in terms you can feel, lead melts at 327 degrees Celsius. Zinc melts at 420 degrees. The surface of Venus is hot enough to melt both of them, not quickly, not eventually, immediately. The moment they touched the ground, they would pool into liquid metal. The paradise people imagined was a furnace. And the beautiful clouds? They're not water vapor. They're concentrated sulfuric acid, the same acid used in car batteries. Series, swirling around the entire planet in layers up to 20 kilometers thick. The most beautiful object in our night sky is, up close, one of the most hostile places in the solar system. But here's what really gets me. It didn't have to be this way. Around 4 billion years ago, when the solar system was still young, Venus and Earth formed from the same cloud of gas and dust. Same raw ingredients. Same distance from a young sun that wasn't yet as bright as it is today. And here is what NASA-owned climate models suggest. For perhaps 2 to 3 billion years, longer than the entire history of complex life on Earth, Venus may have had liquid water oceans, a stable atmosphere, surface temperatures between 20 and 50 degrees Celsius. Comfortable, habitable, Earth-like. If there was life in our solar system 2 billion years ago, it was as likely to be on Venus as on Earth. Then something happened. The catastrophe scientists believe that roughly 700 million years ago, Venus went through a catastrophic resurfacing event. Massive volcanic eruptions, on a scale we have never seen on Earth, flooded the planet's surface with lava. The volcanoes pumped enormous amounts of carbon dioxide into the atmosphere, far more than the planet's rock cycle could absorb. And then a process began that could not be stopped. Carbon dioxide traps heat. More heat meant more evaporation. More water vapor in the atmosphere meant more heat trapped. More heat meant more evaporation. The cycle fed itself, faster and faster, until the oceans boiled away completely. The hydrogen from the water escaped into space. The carbon dioxide stayed. The atmosphere grew thicker and heavier with every passing century. In geological terms, it happened fast. Within roughly 125 million years, a blink of cosmic time, a planet that may have had oceans and rivers and storms became the hell world it is today. The oceans of Venus are gone. Every drop evaporated, broken apart, lost to space forever. What remains is a dense, crushing blanket of carbon dioxide, 93 times heavier than Earth's entire atmosphere, pressing down on a surface hot enough to melt metal. Venus didn't just die. It was transformed into the worst possible version of itself. And here is the thought that should make you genuinely uncomfortable. The same process, CO2 buildup, greenhouse warming, runaway feedback loop, climate scientists study on Earth today. Venus isn't just our neighbor. Venus is our cautionary tale, a demonstration, hanging in our sky every night, of where a planet can go when its atmosphere tips past the point of no return. But today, we're not here to talk about Earth's future. We're here to talk about what would happen if a human being tried to go to Venus right now. And the answer starts before you even get there. People sometimes assume that because Venus is our closest planetary neighbor, getting there must be relatively simple. It's closer than Mars, after all. That assumption is wrong in a very specific, very dangerous way. The fuel problem nobody talks about when a spacecraft travels to Mars, it moves away from the sun. As it moves outward, it naturally slows down. The sun's gravity pulls it back. That's actually useful. It means arriving at Mars requires less fuel to slow down and enter orbit. Venus is the opposite. Venus is closer to the sun than Earth. When you travel toward Venus, you are also traveling toward the sun. Gravity accelerates you. You arrive going faster than you intended, much faster. And to enter orbit around Venus, instead of flying past Io, you have to burn enormous amounts of fuel to slow down. This is not a small engineering challenge. It is the reason NASA has sent far more missions to Mars than to Venus, despite Venus being closer. Reaching Venus efficiently is harder. Getting into orbit around Venus costs more fuel. And fuel is everything in spaceflight, because every kilogram of fuel you carry requires more fuel to carry it, which requires more fuel to carry that, and so on. A human mission to Venus would require a spacecraft significantly larger and more complex than anything we've ever built for deep space travel. And that's just the fuel problem. What the journey does to a human body, the trip to Venus, using current propulsion technology, takes between 3 and 6 months. During that entire time, the astronauts would be floating in microgravity, and microgravity does terrible things to the human body. Bones lose density at a rate of about 1 to 2% per month in space. Muscles weaken. The heart shrinks slightly because it doesn't need to pump against gravity. Fluid shifts upward into the skull, increasing pressure on the eyes and changing the shape of the eyeball, causing vision problems that may be permanent. After 6 months in space on the way to Venus, an astronaut would arrive weakened, with compromised bones, potential vision damage, and a cardiovascular system that has partially adapted to a world without gravity. Then they would try to land on a planet with a surface gravity 90% that of Earth's. But we are getting ahead of ourselves, because there is something that would be attacking the astronauts the entire journey, something invisible, and arguably worse than anything the human body loses in microgravity. The invisible killer space is filled with radiation. Cosmic rays, high-energy particles fired across the galaxy by dying stars and black holes, stream through the solar system constantly. On Earth, our planet's magnetic field and thick atmosphere deflect almost all of them. We are protected without even knowing it. In deep space, there is no such protection. During a 6-month journey to Venus, an astronaut would absorb radiation at rates that significantly increase their lifetime risk of cancer. Radiation also damages the brain. Studies of astronauts returning from long missions have shown structural changes in brain tissue, shifts in cerebrospinal fluid, and subtle but measurable effects on cognitive function. And here is the thing about a Venus mission specifically. Venus is closer to the sun. The radiation environment around Venus is more intense than around Earth or Mars. The sun itself, in addition to cosmic rays, bombards Venus's orbit with solar wind and solar particle events, sudden intense bursts of radiation that can deliver a dangerous dose in hours. A spacecraft heading to Venus would need extraordinary radiation shielding, but shielding is heavy, and heavy means more fuel, and more fuel means a bigger, heavier spacecraft. Every solution to every problem on a Venus mission creates a new problem. The mission eats itself before it even launches. You've survived the journey. 6 months in space, radiation, bone loss, isolation. You are now in orbit around Venus. Look out the window. The planet below looks almost peaceful from up here. A smooth sphere of pale yellow-white clouds, completely featureless, covering the entire planet without a single gap. There is no glimpse of the surface. No continent, no ocean, no landmark. Just an unbroken blanket of clouds stretching from pole to pole. You will never see through those with your eyes. The surface of Venus is permanently hidden from space, and somewhere beneath them, 65 kilometers down through layers of sulfuric acid and crushing atmospheric pressure, is a surface that nothing human-made has ever survived on for more than 2 hours. The atmosphere is a weapon. Let's talk about what you would face if you tried to descend. At the top of Venus's cloud layer, around 65 kilometers above the surface, the conditions are actually the most Earth-like in the entire solar system outside of Earth itself. The pressure is similar to Earth's at sea level. The temperature is around 75 degrees Celsius, hot, but not instantly lethal. For a brief moment, descending through the upper clouds, things might almost seem survivable. Then you keep going down. As you descend through the clouds, the sulfuric acid becomes more concentrated. The droplets in the air eat through materials. The temperature climbs. The pressure begins to build. By the time you reach 50 kilometers altitude, the pressure is already 1 Earth atmosphere. By 30 kilometers, it is 5 atmospheres, like being 40 meters underwater. By 10 kilometers, 30 atmospheres. By the time you reach the surface, the pressure is 92 times that of Earth's atmosphere. That is equivalent to being nearly a kilometer beneath the surface of the ocean. No human being can survive that pressure. No spacesuit ever designed or even proposed can maintain structural integrity under 92 atmospheres of force while also withstanding 467 degrees of heat, while also resisting sulfuric acid corrosion. These are not 3 separate engineering challenges that might each be solved. They are 3 simultaneous, compounding, catastrophic conditions that no material we currently know of can endure for more than minutes. What happened to the robots we sent? We know exactly what Venus does to things that arrive there, because the Soviet Union sent probe after probe to find out in one of the most determined and punishing scientific programs in space history. It was called the Venera program. Between 1961 and 1984, the Soviet Union launched 16 Venera spacecraft toward Venus. Many failed before even reaching the planet. Several were crushed or melted in the atmosphere before reaching the surface. A few made it all the way down. Venera 7 in 1970 was the first spacecraft to successfully land on another planet. It was massively overbuilt, designed to withstand pressures and temperatures far beyond what scientists thought existed at the surface, just to be safe. It landed. It transmitted data. For 23 minutes. Then, Venus killed it. The Soviets kept trying, kept improving. Venera 13 in 1982 was their greatest achievement. It landed, took the first color photographs of the Venusian surface, a bleak orange landscape of flat volcanic rocks stretching to the hazy horizon, and transmitted data for 2 hours and 7 minutes before being destroyed. 2 hours and 7 minutes. That is the record. That is the longest any human-made object has ever survived on the surface of Venus. Think about what that means for a human being. We cannot build a robot that lasts more than 2 hours on Venus. We cannot build a probe. We cannot build an unmanned lander. The planet destroys everything we send. And yet imagine, for a moment, a human astronaut somehow standing on that surface in some future suit we cannot yet design. Even if the suit held, even if the pressure didn't crush them, and the heat didn't cook them, and the acid didn't eat through the seals, they would have perhaps minutes, perhaps an hour, 2 hours at the absolute limit of imagination. And then they would need to get back to orbit. This is the moment I promised you at the beginning. This is why anyone who goes to Venus will never come back. Even if we imagine a future technology that solves the heat, that solves the pressure, that protects a human being somehow on the surface of Venus, there is a problem that has no solution with any technology we can even theorize. Getting back off the surface. The launch problem to leave Venus and return to space. A rocket must accelerate to orbital velocity, roughly 7.3 kilometers per second. That is not unusual. Earth rockets do something similar when they launch. But there are 2 things that make launching from Venus's surface essentially impossible. First, the atmosphere. Venus's atmosphere at the surface is 92 times denser than Earth's. A rocket trying to launch through it would experience drag forces far beyond what any currently designed rocket could overcome. The dense, supercritical carbon dioxide at the surface behaves almost like a fluid, pressing back against anything trying to push through it. Second, the heat. Rocket engines and fuel systems are designed to operate within specific temperature ranges. At 467 degrees Celsius, most rocket fuels break down before they can ignite properly. Fuel tanks to form, pump seize, electronic systems that guide the rocket fail. Everything that makes a rocket work stops working at Venus surface temperatures. This is not a problem we can engineer our way around with better materials. The fundamental laws of chemistry and physics make launching a rocket from Venus's surface, with enough thrust to reach orbit, effectively impossible with any technology, even theoretically, on the horizon. If you land on Venus, there is no launch. There is no return. Even orbit is a trap, but let's go further. Let's imagine someone stayed in orbit around Venus and never descended. Could they come home? Remember the fuel problem from the journey there. You arrived at Venus going very fast. The sun's gravity accelerated you. You burned enormous fuel to slow down into orbit. Now you want to leave. To return to Earth, you need to accelerate in a specific direction, at a specific time, when the orbital geometry is right, when Earth and Venus are positioned correctly relative to each other. These launch windows occur roughly every 19 months. If you miss your window, if your spacecraft is damaged, if someone is too ill, if a system fails, you wait 19 months in orbit around Venus, closer to the sun, with more radiation, with food and oxygen running low, with a crew that has already been in space for 6 months just getting there, and the fuel you burned slowing into orbit, it's gone. You need new fuel to accelerate out. Where does it come from? There is no fuel depot at Venus. There is no resupply mission. There is no mechanic. There is nothing between you and the void. Venus is not just physically lethal on its surface. It is a trap in space, a gravity well positioned such that reaching it consumes enormous resources, and leaving it requires resources you almost certainly no longer have. The physics of Venus's location in the solar system, combined with the conditions on its surface, create a one-way door. You can go to Venus. You cannot come back from Venus. I want to take a moment away from the physics, because behind all of this, behind every failed probe, every crushed lander, every melted sensor, there are human beings who dedicated years of their lives to understanding Venus. People who sat in rooms in Moscow, in Pasadena, in Tokyo, staring at data transmitted from the surface of another planet for 23 minutes, or 57 minutes, or 2 hours before the signal went silent. The Soviet scientists of the Venera program spent 2 decades launching spacecraft at Venus. Most of them failed. Many were crushed before they reached the surface. But everyone that succeeded told us something new, confirmed something that had only been theory, showed us what the surface actually looked like. When Venera 9 returned the first photograph from Venus's surface in 1975, the scientists in the room reportedly stood in silence. For the first time in human history, they were seeing another world with their own eyes, not through a telescope, not as data, as an image, rocks on the ground of a planet, another planet that had been hanging in Earth's sky since before humans existed. Flat volcanic rocks, a horizon, an orange hazy sky. For 53 minutes, they had a window into hell. Then Venus claimed the probe, and the window closed. There is something deeply human about that. We cannot go there. We cannot survive there. But we looked anyway. We built machines to see what we couldn't see with our own eyes, and we sent them into the most hostile environment in the solar system just to know. That is not foolishness. That is the best version of what we are. So is Venus forever off limits? Perhaps not, but the answer might surprise you. Remember that layer at 50 to 54 kilometers above Venus's surface, where the pressure matches Earth's and the temperature is between 20 and 75 degrees Celsius. Where it's hot, but not impossible. Some scientists have proposed that the future of Venus exploration isn't on the surface at all. It's floating above it. A concept called a Venus atmospheric station, essentially a crude blimp or balloon habitat floating in the upper cloud layer, could theoretically survive in those conditions for extended periods. The same thick clouds that make the surface inaccessible would provide the buoyancy to keep such a habitat aloft. Solar panels would work efficiently at that altitude. The temperature, while hot, is manageable with insulation. NASA has actually studied this seriously. It is called the High Altitude Venus Operational Concept, or HAVOC. It is not a fantasy. It is a real engineering proposal, peer-reviewed, taken seriously by space agencies. Would people who went on such a mission be able to return to Earth? That depends. A flyby mission, going to Venus, floating in the atmosphere for a period, then using the planet's gravity to slingshot back to Earth is theoretically possible. No landing, no surface contact, just the clouds. But reaching the surface, living there, that remains, with everything we understand about physics, chemistry, and the human body, effectively impossible. Venus will not open its door to us. Not for a very long time, perhaps not ever. Tonight, go outside and look for it. Venus is usually visible just after sunset or just before sunrise, the brightest point of light in the sky that isn't the moon. You cannot miss it. And when you find it, I want you to hold two things in your mind at the same time. The first, what it looks like. A calm, steady, beautiful light. The morning star, the evening star, the planet that civilizations worshipped and named after the goddess of love. The second, what it is. A world that was once perhaps like ours, with oceans, with clouds that carried rain, with a sky that wasn't made of poison. A world that tipped past the edge and never came back. Ice hot enough to melt lead, crushed under the weight of an atmosphere heavier than the ocean, wrapped in clouds of acid, lit by a dim orange glow that no human eye has ever seen in person. Venus is not just a planet, it is a mirror. It shows us what happens when a world goes wrong. It shows us what a habitable planet looks like after it loses everything that made it habitable. It shows us that even in a solar system with billions of years of history, a world can change beyond recognition in what amounts to a geological instant. And it hangs there in our sky, close enough to see with the naked eye, close enough that on a clear night, you can almost imagine what it would feel like to stand on its surface, reminding us, every single night, of what we have here. This thin shell of air, this mild temperature, these oceans that haven't boiled away, these clouds made of water, not acid. We live on the planet that didn't go wrong, at least not yet. If Venus makes you feel something, that strange mix of terrified and grateful, drop it in the comments below. I want to know what goes through your mind when you think about a planet that used to be like ours. And if this video gave you something worth thinking about, share it with one person. That's how these ideas travel. Subscribe if you want to go deeper into the universe every week. We've got more worlds to explore, and not all of them are as forgiving as this one. I'll see you in the next one.